A very important question. Form the differential equation of the family of circles in the second quadrant and touching the coordinate axis. Now, x minus a whole square plus y minus b whole square is equal to r square represents an equation of a circle with center a comma b and radius r. Now, since circle lies in the second quadrant, and touches the coordinate axis, therefore a is less than 0, b is greater than 0 is equal to r. Coordinate of center, now it becomes minus a to a and radius is equal to a. The equation of circle in second quadrant is x plus a whole square plus y minus a whole square is equal to a square. Now, arbitrary constant a is equal to arbitrary constant. Now, let this be equation 1. Now, differentiating equation 1 with respect to x, 2x plus a plus 2y minus a with dy by dx is equal to 0. X plus a plus y minus a, y derivative is equal to 0, y derivative is equal to dy by dx. Now, x plus a plus y derivative minus a y derivative is equal to 0, or we can now write it taking a common. A is common, then 1 minus y derivative is equal, 1 minus y derivative plus x plus y derivative is equal to 0. X plus a plus y minus a, okay. So, we are getting x plus a y derivative minus a y derivative is equal to 0, okay. Now, we are having y derivative is equal to, a is equal to, now a is equal to negative of x plus y derivative upon 1 minus y derivative. Or this can be written as a is equal to x plus y derivative upon y derivative minus 1. Now substituting, value of a in equation 1. Now this is equation 1, so we are having now x plus y derivative upon y derivative minus 1 whole square plus y minus a x plus y derivative upon y derivative minus 1 whole square is equal to x plus y derivative upon y derivative minus 1 whole square. Now taking LCM and then eliminating y derivative minus 1 whole square from both the sides, what we are getting? X y derivative minus x plus x plus y derivative whole square plus y derivative minus y minus x minus y derivative whole square is equal to x plus y derivative whole square. Okay. So now this becomes x y derivative plus y derivative whole square plus x plus y whole square is equal to x plus y derivative whole square. Now here these two terms are cancelled and this becomes negative of y minus negative of x. So we can write it x plus y whole square. Okay. Now this can be written as now y derivative whole square x plus y whole square plus x plus y whole square is equal to x plus y derivative whole square. Now x plus y whole square with y derivative whole square plus 1 is equal to x plus y derivative whole square is the required differential equation. This is the answer. Okay.